So hello guys, welcome in this series of lectures of J Advanced Compendium of Definite Integrals. In this series we shall solve previous year questions of J Advanced of definite integral. So this is another question that has been asked in J Advanced 2016. So let's solve it. Looking at the problem itself and looking at the lower limit and upper limit, we can see that the sum of limits is 0. So this clearly hints us to use the king rule. So we should use king rule here. So I equals to, as the problem says, that I equals to minus pi by 2 to pi by 2, and this is x square cosine of x divided by 1 plus e to the power x into dx. If we'll use king rule, and this would be, we can write this as a 2i, and this 2i equals to integral minus pi by 2 to pi by 2, and this is x square cos of x upon 1 plus e to the power x plus of minus pi by 2 to pi by 2, or because limit is same, so we can simply add it here, and this is plus of we'll, instead of x, we'll use the king rule says that integral a to b fx equals to integral a to b f of a plus b minus x. Okay, so that's what we shall use. So here instead of x we shall write minus x, so it will be x square, because minus x to whole square is x square, and cos of minus x is cos x upon 1 plus e to the power minus x. So if you will take LCM, this will be e to the power x plus of 1, and the denominator of this will be multiplied here, e to the power x. Okay, and we have to integrate this. So we can take something common, and that is very obvious that what if to take common, we can take common x square cos x from numerator. Okay, then what we are left with is 1 plus e to the power x, and in denominator e to the power x. Okay, and this cancels here, this is dx, and this is 2i, so I can write I equals to 1 by 2 this. Okay, now, or let it keep it 2i for simplicity. Now we are left with integral minus pi by 2 to pi by 2, and this is x square cosine of x. Okay, this is x square cos x. Now in such integrals we know a technique that's called tabular integration, so we'll use tabular integration. So this I am solving here. So in tabular integration we write one, this will be first term and this will be second term. We write the function that should be differentiated and the other one that should be integrated. So here we will differentiate it. This is 2x. Using tabular integration I am doing this. This is sine of x, this is 2, and what is integral of sine? That is minus cos. Okay, and this is 0, and this is minus of sine. I think that's right. And what we do is we go with plus, alternate plus and minus. So this is plus, this is minus, this is again plus. So integration of this, we can write this as x square sine x, x square sine x, limit minus pi by 2 to pi by 2. This minus minus become plus, so this is 2x cos x, again limit minus pi by 2 to pi by 2, plus of, and this plus minus becomes minus, so this is minus 2 sin x, this is from minus pi by 2 to pi by 2. Okay, if we'll put this limit here, we can solve this. This is pi square by 4, and this minus becomes plus here, so this again also becomes pi square by 4. Okay, and this will be 0 because cos of pi by 2 is 0, so this whole thing will be 0. This is very obvious, and this will be minus 2, sine of pi by 2, this is 2. Okay, so this equals to 2i. This implies that I equals to, I will multiply it by 1 by 2, so this becomes pi square by 4, because this add up to 2 pi square by 4, and 2 cancels here, so this is pi square by 4, and this is minus of 2. Okay, so I think we can see this is the option number A. So this is an easy problem, and this is a very beautiful use of King's rule. We'll see a few more problems and then we'll solve it. Okay, so let's jump to the new problem.